Ladies and gentlemen, welcome to another episode of the Crypto Chronicles, and our first ever episode where we have managed to successfully invite a guest onto the broadcast to talk to us about their area of expertise. Lingo, I'm going to pass the mic to you. Tell us a little bit about who we're hosting this evening.
This is another friend that we met at that Daily Gway meetup in Denver. We were all sitting around the table there, and this is Damathi, and he works at the Ethereum Foundation. As a researcher, he has a little bit more insight than you and I and can help us dig a little deeper into some things.
Hey everyone, it's an honor to be your first guest.
Well, we're honored to have you, a person of
Yeah.
such esteem, direct contact with the Ethereum Foundation. Can you tell us a little bit about what you do and what you want to talk to us about today?
I mostly do research at the core protocol level with some writing. I do some write-ups to explain the items of the roadmap. If you remember the whole diagram that Vitalik shared, I like to explain every item in the road. The next big thing is going to be EIP 4844 coming up in the next fork, which we don't have info on the exact timeline yet, but it's going to be pretty great.
And are we going to find out tonight a little bit about what that might entail?
Yeah.
Awesome. Where are we at? What is the problem that the EIP, we did a special already that talks a little bit about what EIPs are and how they're sort of like the legislation and new rules that the network is going to abide by and follow and hopefully be improved by. What are the problems that this upcoming EIP intends to address and solve?
Yeah, the IP 4844 is basically the very first step of the data sharding, which has always been on the roadmap since the beginning. Like the concept of sharding is taking multiple forms, but now, ever since Dankrad, another researcher on the Ethereum Foundation, introduced the concept of dank sharding. He did not pick that whole name himself.
Okay.
That was big. That was going to be the mechanism for how we do sharding at layer one. And to go back a little bit in time, at first it was going to be what we call execution sharding. With the general gist of it was we're going to have multiple blockchains in parallel processing transactions to increase throughput. But it turns out that's very complicated to do, and whenever we're going to be done doing that, then we're going to be rollout layer two, scaling way better than what we can do at layer one. We ended up scrapping the execution part and only keeping the data. By the way, you can jump in with any questions if I'm just rambling too much on the technicals.
Okay. Yeah. Well, I mean,
Just
the
realize that.
principle it is, there's a lot of technical speak.
Yeah.
There's all right, so sharding. We're talking about the concept of sharding. A shard is a piece of something. What's going on there when we talk about sharding?
That's a concept that already exists in computer science, database management,
Okay.
engineering. And the idea is to apply it to blockchain so that instead of being limited by the number of nodes, right now, what we have is the more nodes we have, the more strain there is on the network. But if instead we split that
Really?
blockchain, yeah,
More nodes means more strain. Okay. I would think that that would alleviate
it,
the load a little bit in some way.
that's the goal with sharding. Like you split the processing among all the validators so that everyone does a little bit of the work, and it ends up that having more nodes is going to help with scaling. That the whole set scaling trilemma is going to be like inverted on its head with sharding.
Okay. And gosh, what was another term that I was so it's gonna make the network run on this is going to decrease energy inefficiency? This is gonna make it more energy efficient, or what when you talk about a load, it's gonna require
It's
less
all about
processing?
scaling.
Okay.
It's all about scaling the blockchain. We have more throughput, but it's gonna be at layer two. All the rollups are the ones gonna be using the sharded data that EIP 4844 is gonna introduce.
It's preparing for anticipated growth. When we're talking about scaling, we're talking about the network being able to get
Yeah,
larger without any potential problems.
yeah.
Okay, cool. Lingo, any other points of information or terminology? I'll try to keep a running list as Dom talks of stuff I want clarification on.
Nope. That all made sense to me. Sharding is kind of separating the workout so that every computer doesn't have to verify everything. You kind of split it up a little bit so that maybe
Okay. It
50.
compartmentalizes the task maybe at each node. Each node is responsible for a different part of the coding or the validating? Or I can't remember. Did you say this was execution layer or
It,
consensus layer stuff?
it's a cross layer update. So we have a new
Okay.
transaction type on the execution layer that's going to include data, what we call data blobs. So that's
Okay.
the biggest part of for the first step towards dank sharding. That right now we have block space as we all know it, and we're gonna introduce another concept alongside it called the blob space for the rollups. That's all the rollups are gonna be batching data that they need for their operations onto layer one in that blob space. And
Best analogy for that I've heard is like the city is block space and how big the roads are is the blob space.
Okay.
Does that make sense to you, Dom?
yeah, it kind of makes sense. I would say it's like scaling in layers, so you have a limited amount of land. Like the rollups are like skyscrapers that you can have more people on top of the same area of land. So,
A- And then 4844 is like a new blob car that it doesn't necessarily need new roads, but it is a bigger car that can carry more transactions than the previous car that we had on the road.
yeah,
Okay. Less trips necessary, more can be carried in one transaction or
yeah.
I guess. Okay.
It's going to be one transaction at layer one that has data inside this blob that gets committed to layer one. But all this data is going to be transaction data that people did on layer two. All these rollups, all these rollup sequencers are going to be batching into blobs. That's where the scaling is going to happen. It's at layer two.
Okay. Can we elaborate a little bit on the relationship between layer one and layer two? I know um, layer one is, in a sense, more foundational.
Yeah.
And layer two exclusive to just certain functions of the network, or what's the role of layer two in relationship to layer one?
Layer two, the way I like to think about it, it's basically a blockchain inside a blockchain. They don't have to worry about ordering things because they just offload that onto Ethereum. Like you got Arbitrum that has their own internal state with transactions. Like you can send money in Arbitrum and bridge it back to your layer one. It's like Arbitrum is its own blockchain, but they don't need to have all these validators to have to like compute. You don't have to have all these nodes computing the same transactions. You can only have one sequencer that compute batches on layer one, and
Mhm.
then anyone that just following along at like Ethereum layer one knows what's going on Arbitrum.
Hmm.
I know
So sort of like provinces within a country or states within the United States sort of a
kind
thing?
of.
There's a degree of independence within entities on layer two, but they all prescribe to the same rules and functions of
Yeah,
layer one?
yeah. And the goal is to have layer two be the way to scale the execution, and layer one only scales data. It's this whole complicated concept of data availability at layer one, which is what rollups require. That's like the biggest thing that they consume from layer one. Like there's a little bit of execution that they pay for to like, for example, ZK rollups. You're gonna have a layer one smart contract that's gonna verify these proofs, the validity of the ZK rollup. The idea is that layer two inherits all the security of layer one.
And data availability is like the most important thing for blockchains, right? Because this is just now like all a blockchain is a digital ledger. We're all just keeping track of information on a blockchain, and it's getting expensive to use Ethereum, as we all know. And we're trying to make this technology cheaper for everybody to use because it's pretty valuable.
Yeah, that's okay. Something that I've encountered within the last couple of months is in the event that someone wants to conduct a transaction, someone wants to pay me in crypto, there's been a switch in the last couple of months where they prefer to use a layer two transaction to a layer one. Is there any explanation as to what changes there have been in the price or the cost of transactions and why layer 2 is a little bit less expensive or less costly in gas?
It basically boils down to compression. Like if you have like 1,000 transactions on layer 2, they're going to be compressed into a single transaction at layer 1. It cuts down on a lot of the overhead instead of everyone spending all that money doing the computation at layer 1. It gets computed at layer 2 and it gets patched on layer 1. So the rollup only pays for data. It doesn't really pay for execution. This is why 4844 is going to be a game changer for rollups, because right now they have to pay in gas. They have to pay gas fees to both data in what we call data, or when they do a smart contract to call. They both all that data is pretty expensive relatively compared to what 4844 is going to be. And not only that, but also the gas market at layer 1 right now is like very bunched up together. So when execution is congested, then data also follows, because 1 byte of call data is 16 gas. Whenever people are doing NFT drops or swapping on the Uniswap, and that's a lot of execution. It's not a lot of data, but it still drives up the price of data. And with 4844, we're splitting these two markets. So there's going to be the market for data and the market for execution. Rollups are going to be unaffected whenever layer 1 is very congested in execution.
Can you guys explain to me? I've heard the term rollup used a lot. What does a rollup do, or how does a rollup function?
The layer 2 blockchain within the blockchain.
Okay.
They're called rollups because they roll up transactions onto layer 1.
Okay. So, and rollup is like Arbitrum
Yeah,
is a rollup.
yeah.
Okay.
Arbitrum is a rollup.
And
There's ZK Sync, there's Scroll, there's a lot of layer 2 like competing over the same layer 1 settlement.
okay.
Like Ethereum layer 1 is the settlement layer. That's the glue for all these rollups.
Okay. Is each layer 2 token a rollup, or might a rollup have a bunch of tokens that it uses within that rollup?
It's like any blockchain, really. Like you have the native currency to pay for transaction fees on the layer 2. And right now, most of these rollups, they all use ETH as the currency to pay for transactions.
Right.
But it's the same way how like you have Polygon, the side chain. They have Matic for their gas fee. But if there were a rollup, they wouldn't necessarily have to use Matic. But behind the scenes, they all have to pay ETH to layer 1 whenever they want to commit their transactions.
Gotcha. Okay. That's an example of a rollup. And Lingo, help me out with picking his mind on the EIP.
I heard that there's also, like you were saying, that 4844 is a precursor to sharding down the road.
Yeah.
And I've heard that there's also precursors to 4844 that made 4844 possible. It would, let's see, I got them written down right here. It was EIP 1559. It said that just like 4844 is a new type of car on the road that can hold more data, 1559 was like a new way for those cars to pay for gas rather than an auction. There's a base fee.
Yeah.
And then EIP 2718 is a new rules that says cars come with different types, each with its own features. Before this, all cars had to be exactly the same.
Yeah, that's the EIP for the transaction type, right?
Yep. This allowed us to have different kinds of transaction cars rather than, different types of transactions rather than just one. I don't know.
Where EIP for 1559 added a new transaction type for like when you make a transaction. Before, well, for 1559, you would put a transaction, you would say, this is how much I'm going to pay per gas. And 1559 made the market more efficient by having a new transaction type where instead you say, I'm willing to pay up to that much. And there's the base fee, like you mentioned, that goes up and down depending on how congested the network.
But I guess there was just different EIPs that kind of tied into 4844. So it's just another thing to talk about. Basically, a new way to pay for gas. We had an improvement proposal that allowed us to have different kinds of cars on the road, new gas, bigger cars that can carry more people. And then EIP 2930 is like a special pass that lets cars tell the toll booths ahead of time that the roads they're going to be on. This can make things faster because the toll booths can get ready for them in advance. The new blob cars use these special passes too.
These Bob cars are, I'm not sure if they use access lists. I just know the transaction type is going to specify the commitment to the data that's going to be posted, as well as the price they're going to be paying for this new resources of data that's called data gas. Because that's not already complicated enough calling everything gas.
Right. There you're saying how things were separated into data and execution.
Yeah.
Is that what you're saying? And then, so now we have execution gas and data gas.
Yeah. This new transaction type is what roll-up sequencers are going to be using to compress all the execution happening at layer 2 into layer 1 data, which is going to be cheap for the roll-up sequencer and the roll-up users. There's going to be this whole pipeline that transform execution at layer 2 into data at layer 1.
Does
So
any of this bring up new questions for you?
yeah, okay. After the implementation of this EIP, is there the phenomenon of people preferring layer 2 level transactions? Are people gonna go back to wanting to do layer 1 transactions, or because the price is gonna be reduced, or is this going to be able to accommodate just what's the anticipation of the layer for transactions in the future, I guess?
It's it's already cheaper to use layer 2 today. And
Mhm.
it's going to be much cheaper after that. So they're going to be able to scale their throughput. But in terms of layer 1 execution, if the people that want to pay you in crypto today want to use layer 2, they're going to continue wanting to use layer 2 because it's going to become faster and cheaper thanks to the CIP.
Gotcha.
And it won't affect layer 1 though, right?
Yeah, if you're doing swaps or NFT drops on layer 1, then that's still going to be still going to congest the execution, and you're going to be paying higher gas fees. This is what EIP 4844 with the two distinct markets for data and execution that's going to shield the rollups from paying congestion prices when there's a lot of execution going on at layer 1.
Why are people incentivized to use layer 1 after this if layer 2 is going to be faster and cheaper? Is that more security? What's the advantages of layer 1 versus layer 2?
Layer 1 is the most secure by far right now.
Okay.
Layer 2 there's still a lot of them are in beta form where there's a lot of centralized components that need to progressively decentralize, namely the sequencers and the fraud proofs for the optimistic labs.
Yeah.
If
I
you really want to pay for security, you're going to be using layer 1.
And availability also. I've had to Lingo help me one whole afternoon to figure out how to tap dance a layer 2 transaction into the right wallet, because there are a lot of restrictions about what could be accepted where, and which wallet could function with it. We had to move it around a few times before we finally got it to the right wallet in the right form. I definitely know that there's some growth that could be done in terms of layer 2 of availability or ability to
The user
accommodate it.
experience. Yeah.
Right. Yeah. The user
Cool.
experience was terrible.
Yeah.
Oh, UX, yeah, thumbs down
Yeah.
on
This is a
the
pain
UX.
point in all of crypto right now, I would say. But all the effort are focused on scaling and decentralization. But I have no doubt the UX is going to be the next big thing for priorities.
Do a lot of these roll-ups have a staff dedicated exclusively to UX, or is that sort of an afterthought, or any idea?
Well, the biggest rollups are EVM rollups. It's the same UX, more or less the same UX that you have on layer 1, where you use MetaMask and you connect your wallet to Uniswap or something. There are other rollups that aren't EVM and I'm not really sure how they do their user experience or how they allocate these priorities.
What does EVM stand for?
That's
Any
a
idea?
Ethereum virtual machine.
Okay. I've heard that thrown around for months and I had no idea and what does it represent then? A
That's
whole
basically the computer that runs inside Ethereum. You know how a computer is just follows a series of instructions to like input, output. That's
okay.
the AVM is like how this is processed on the blockchain.
Okay. It's not exclusive to layer 2 or it's just I don't know. I'm trying to figure out how the term is employed. Is it just a term associated with in the crypto lexicon or does it refer to a specific group of functions or programs?
Is it kind of like the software that you use to run the blockchain?
Yeah, pretty much. It's like you have a transaction that calls the Uniswap contract, and this is where the EVM code is going to be executed, like the bare, like the lowest layer of the really like bytecode, like put this byte at register 1 and add it to the byte at register 2. Like this is the EVM at its like deepest components.
And that's a
Yeah.
term.
So you know how like you download Windows
Mhm.
and that's your operating system or
Mhm.
Mac.
Yeah.
Like when you download, and I don't know if you've ever played with a virtual machine, but you can like build another computer inside your computer.
Oh.
I think that my understanding of what the EVM is like when you download the software and you plug it into the system, that whole thing, everybody's node running that software is the Ethereum virtual machine.
Okay. All right. So
Is that right, Dom?
Yeah, pretty much.
it's a term totally exclusive with the Ethereum network, and when that term is used, that's an ETH maxi term, sort of somebody who operates primarily or exclusively on the Ethereum network would talk about EVM.
Well, the
It's the
EVM, I wouldn't say it's an ETH maxi term. It's really just the term for this component of the blockchain. So
Okay.
you know how you know the Solidity smart contract language? Like you make your dApp, you write code, and then you compile it to EVM bytecode. So
Okay.
it's like a normal programming language in the non-blockchain world. It like it's
Oh,
readable.
really?
And you can compile it to a .exe file, which is like what the computer understands. It's all the zeros, the ones and zeros.
Okay.
Equivalent, but for Ethereum, you compile like a source code into EVM bytecode. And this is what is going to be ran by all these transactions, which is what
And nodes, this is the language that nodes use to operate their ledgers.
yeah, you got the nodes are following the blocks and the blocks contain transactions. And like you have to execute the transactions to figure out the state of the blockchain for the next block.
Okay.
everybody's nodes all trying to do the same thing, right?
Yeah, to agree on the rules of the EVM. If someone decides that says this transaction gives me 1,000 ETH, have been out of thin air, like that's not going to be valid because the node running all the other nodes are going to try to execute the transactions and they're going to see that it's invalid. If you try to post a block that says I have 1,000 ETH now, people are just going to reject your block and not follow this fork that you're doing of the blockchain.
It's a lot to digest for someone
Yeah.
who's a novitiate to the world, but I appreciate you guys understanding and trying to break it down in simple terms.
To tie it back with the broader conversation about rollup, that's kind of the bottleneck of throughput is that every node executes every transaction. You can see that's kind of like wasted computation in a way that like you have to cater
It's
the limit.
redundant. It's too much of the same thing
Yeah,
from different
pretty much.
nodes.
But it's necessary for a like the way Ethereum is set up is that there is a limit on how much execution you can do in a single block
Okay.
that so that nodes can keep up. So like if you want a decentralized network, your computer, your normal computer, your laptop has to be able to run an Ethereum node. If we just jack up the limit to like 1000x, then a lot of these small nodes running small hardware are going to not be able to keep up and they're going to drop out. And then you're going to be relying on data center nodes and big computers that nobody can afford except like a few people, few companies, or so that's kind of the throughput for like decentralization versus scaling. If you try to scale this way at layer 1, you're going to sacrifice on decentralization. But the goal of layer 2 is to have both scaling and decentralization. Makes sense.
It does a little bit, and on a semi-related question, and I guess this is an execution layer issue. Geth is an execution
Yeah.
layer.
That's an
So
execution client.
what are your thoughts on the Geth majority, and what do you think are ways to broaden or balance or decentralize that situation?
It really comes down to like community highlighting that issue of the get supermajority. But we managed to do it with the consensus clients, and now we're doing it with execution clients where Geth has basically been the standard, and the other clients weren't as good or had other issues in different areas. But now they're really becoming battle tested. The Eat Taker bunch there, I know they're really pushing for execution diversity, and we need to bring down the Geth supermajority, that's for sure.
Yeah, I was wondering how it got like that, but they just had proven reliable software. That was
Yeah,
really how.
Geth was the first one, really.
Okay, and they were early.
Yeah.
I guess I was going to
Yeah.
ask what the chronology was for that as well.
Yeah.
They were early and reliable. That makes sense. A good client, just with the misfortune of too many people liking it.
Yeah, pretty much.
Well, we've got about 4.5 minutes left. Lingo, you got a closing question before we wrap it up?
Besides 4844, what other exciting things do you know about or things that you find important in Ethereum's future?
In the future, that's a very broad question with the everything is exciting and important.
Yeah,
Asking
right.
me.
Yeah.
In
Gives you a
the
lot
short
of
future, there's the forge that's going to be coming up alongside EA 4844. There are a few EIPs, and one of them that I find pretty it's important and it's exciting for me because I'm nerdy about that stuff is the beacon block roots inside the EVM execution layer. EVM is going to be able to access the consensus layer state, and it's going to be very helpful for decentralized staking pools that need to see what's going on at the consensus layer. And it's relatively speaking, it's a very small change, but it's a pretty important one. It's very exciting.
cool.
That must help out Rocket Pool then, huh?
Yeah, because right now you have to rely on the ODAO for being like proofs of what's happening at the consensus layer for which validator has the balance of each validator, and to like proportionally distribute the rewards and everything. But now, if the EVM is able to access the state, then you can have like fully trustless proofs of execute consensus layer balances. That's gonna remove a lot of trust that people rely on for the Rocket Pool ODAO.
Really, all this stuff is just a bunch of technical upgrades that the blockchain's going through that's going to make it easier for everybody to use. You know, everybody thinks that blockchain's too expensive and it's just a big ol' fad and it's never going to work and all this stuff. And all these EIPs and everything that everybody's working on at the Ethereum Foundation is just a bunch of stuff that will help everybody else be able to use it alongside us without making it too expensive.
A great summary, Lingo. Way to put it into layman's terms. Dom, thanks a lot for joining us. When I guess there's no definitive date for the rollout of this EIP, but we can expect it in the fall sometime.
Probably that would be my guess too.
Okay.
But we're going to be following, and it shouldn't be that long before we start talking about hard forking the testnets, and then that gives a better overview of the timeline.
Well,
Awesome.
thank you very much for your time. It's really good to see you again, and we look forward, hopefully, to bringing you back to speak again. Maybe we can get a panel of folks to bat around a few ideas and developments to talk about. I know this is a great learning experience for me, and thanks to Lingo for putting this meeting together this evening. I really appreciate that. We'll get the broadcast up sometime soon for you guys to check it out and share. But
All right.
yeah, until next time, thanks you guys, and we'll talk later.
See ya.